So we learned how to calculate the empirical formula. How could we get the molecular formula? It's always a whole number multiple of the empirical formula. Sometimes the multiple is 1, sometimes it's 2 or 3 or 4, etc. In order to find the molecular formula, we need another piece of information, and that is the molar mass. The mass of 1 mole of the compound. So to find the number that we multiply the empirical formula by, we're going to call that N, we take the molar mass, that would have to be given to you in a problem, and you're going to divide it by the empirical formula molus mass. Yeah, typo. Molar mass. So the actual molar mass divided by the mass of the empirical formula. That should give you a beautiful, very close to whole number. That's what you multiply the subscripts by. So let's do an example. The empirical formula for fructose is CH₂O, and its molar mass is 180.2 grams per mole. What is the molecular formula? So the molecular formula is going to be some multiple of this. It might be multiplied by 1, might be 2, might be 3. Basically, what we need to figure out is how many of these units combined make up the actual molecule. So we're going to take, to find N, we're going to take the actual molar mass, which is given to us, 180.2 grams per mole, and we're going to divide it by the mass of the empirical formula. Oh, I didn't mean to do that. CH₂O. If we find out the mass of this and divide that into the actual mass, we'll find out how many units are in there. So you take the empirical formula and you find its mass. So the mass of carbon, there's 1 mole of carbon in there, and there's 2 moles of hydrogen, and there's 1 mole of oxygen. So 12.01 plus 2 times 1.008 plus 16 equals 30.026. And the units on that would be grams per mole. That wasn't recorded. So I'm going to take this mass that I calculated and I'm going to put it in the denominator here. Those units cancel themselves out. So we've got 180.2 divided by 30.026 equals, and this comes out to 6.0014 blah blah blah. No units. More digits is better than fewer digits here. We don't really need to consider sig figs, but just don't round off too much. So this comes out to 6. What that tells me is that there are 6 of these units in an actual molecule. So N is 6, so that means I take the empirical formula and I'm multiplying all the subscripts by 6. Don't leave it like this. Okay, that's just a way of writing it to help you understand what we're doing. So the actual formula then would be C6H12O6. The actual molecule has 6 carbons, 12 hydrogens, and 6 oxygens. CH₂O is the lowest ratio. That's what you get by decomposing fructose and measuring the masses. Any questions? This is actually a model of fructose. Let's do another one. So butane is a compound containing carbon and hydrogen used as a fuel in butane lighters. Its empirical formula is C₂H5, and its molar mass is 58.12 grams per mole. Find the molecular formula. So to find the number I need to multiply all the subscripts by, I take the actual molar mass and I divide by the empirical formula mass. So one of them is given to me. It's the 58.12 grams per mole. That means 1 mole of it weighs 58.12 grams. And then I need to calculate the other one. So I've got C₂H5, 2 times the mass of carbon, plus 5 times the mass of hydrogen. 2 times 12.01 plus 5 times 1.008 equals 29.06. That's all the digits that my calculator is showing me. So 29.06 grams per mole. So 58.12 divided by 29.06. That one comes out exactly 2. There's no multiplying to get whole numbers on these sorts of problems. If it doesn't come out to be really close to a whole number, that means that you did something wrong in your calculation. And most likely you either punched something into your calculator or you calculated this mass wrong. Just try it again. So 2, I need to take this formula, C₂H5, and multiply the subscripts by 2. The actual formula is C₄H10. This is just the lowest ratio of that. The only way I can figure out what the molecular formula is to have the actual molar mass in a problem that has to be given to you. Any questions? Yay, we finished.